Hi students, this is Al Drushler, and in this video we'll be looking at the objective to add, subtract, and multiply polynomials. Okay, in this example here we want to add three polynomials. We're going to add 2x squared plus 12xy minus 11, 6x squared minus 2x plus 4, and negative x squared minus y minus 2. Alright, so since we're adding polynomials, we don't need to change the signs of any of these polynomials. And you'll see what I mean when we're subtracting in the next example. Because when you're subtracting, you have to change the signs of the second polynomial. Just like if you were changing a subtraction problem, 2 minus 4, to an addition problem, you would write it as 2 plus negative 4. So you're like distributing the negative sign out front. Okay, there's a few ways to do this, but I'll just work this out horizontally. So we can take the 2x squared. Now we look at the other polynomials and we look for any x squared so we can put them next to each other. We have a positive 6x squared. So we can write plus 6x squared. And in the third polynomial we have a minus x squared. These are like terms because they have the exact same coefficients with the exact same exponents. Now we'll look at the next one, which says plus 12xy. I'm talking about the next term in the first polynomial, and we look to the other polynomials. There are no xy's, so that's done. Now we can look at the negative 11 and we look for any constants. So we have a plus 4 and a minus 2. Okay, now you might want to cross off what you use as you go, because you notice we did not use the minus 2x or the minus y. And then there are no other like terms for those. So we just simply write minus 2x and then minus y. All right, now we have a couple distinct groups of like terms. Here's one group. This is by itself, the 12xy. Here's another group. And then these two are by themselves. Okay, so let's add the coefficients of each of these like terms. 2 plus 6 is 8, minus 1 is 7. So we have 7x squared. And then plus 12xy is by itself. So we have a negative 11 plus 4 minus 2. So negative 11 plus 4, that's negative 7. And then negative 7 minus 2, that's negative 9. So we write minus 9. And then we bring down the minus 2x and the minus y. All right, now if you wanted this in descending order, you would put the minus 9 at the end. So we'll put equal signs indicating that all these are equal. So we have 7x squared plus 12xy minus 2x minus y minus 9. Now remember, the coefficients go with the terms. So as you move the minus 9 to the end, you have to take the negative sign with it. Okay, let's look at a subtraction problem. So here we have 2x to the fourth minus 3x squared plus 7x, and then minus 5x cubed plus 2x squared minus 3x plus 5. Now, we could change this to an addition problem if we wanted to. Now, once we change that minus to an addition sign, the subtraction symbol to an addition symbol, we have to change all the signs inside the second polynomial. That's exactly the same rule as if you were going to change a subtraction of whole numbers or subtraction of integers to addition. You change the sign of the second number. So we're changing the signs of the second polynomial. And now we can do our groupings. So 2x to the fourth, and there is nothing else. So let's cross it out. Minus 3x squared minus 2x squared. Now we're using the signs because it's an addition problem now. Okay, then plus 7x plus 3x. And then minus 5x cubed and minus 5 get brought down. So let's group any like terms. So here's a couple like terms. So we have 2x to the fourth minus 5x squared plus 10x minus 5x cubed minus 5. The only final thing we want to do is to write this in descending order. So we'll put the negative 5x cubed after the 2x to the fourth. So 2x to the fourth minus 5x cubed minus 5x squared plus 10x minus 5. Okay, we've subtracted the polynomials and we've written the answer in descending order. All right, let's look at two multiplication problems. Okay, so first I have 3x minus 2 quantity squared. So you're thinking, where's the multiplication problem? Well, if you know, 8 squared means 8 times 8, which is 64. So 3x minus 2 squared means 3x minus 2 times 3x minus 2. Now this is a binomial times a binomial. So you can use what's called FOIL. So you've probably heard that before. First outer, inner, last. What it really means is the product of the first terms. So the 3x and the 3x. So what's the product of that? 3x times 3x is 9x squared. I just did 3x times 3x, the first of each term. Now the outer. The outer is the 3x and the negative 2. So 3x times negative 2. That's negative 6x. Now the product of the inner terms. Negative 2 times 3x. That's negative 6x. And now the product of each last term. Negative 2 times negative 2. That's positive 4. So each of these four terms, when you do FOIL, is a product of two terms. So we have to simplify the middle. 9x squared minus 12x plus 4. All right, so that's multiplying binomials. Now, this is a special example, but if you had 2x plus 7 times 8x minus 4, you use the same process, and you would come up with the answer. Okay, let's look at this. This is a product of three binomials here. Y minus 2 times y plus 2, and then y squared plus 4. So let's first focus our attention on these two. So we're going to multiply left to right. So we'll do y times y, y squared. That's the first. Now we'll do the outer, y times 2, so plus 2y. Now the inner, product, negative 2 times y, so minus 2y. And then the last, negative 2 times positive 2, minus 4. Okay, bring down the y squared plus 4 because we didn't do anything with it yet. Okay, let's simplify. These cancel each other out. So now we have y squared minus 4 times y squared plus 4. Okay, so now we can use FOIL or distributive property again. So the y squared times y squared, y to the fourth. The y squared times positive 4 plus 4y squared. The negative 4 times y squared, negative 4y squared. The negative 4 times positive 4, so negative 16. Now these middle terms cancel out. So this is another special polynomial here. So y to the fourth minus 16 is our final answer here. And let's just add one more multiplication problem. So let's multiply x minus 3 times x squared plus 2x minus 5. Okay, now in this case, we're going to use distributive property. We're going to multiply this x by each term in that next polynomial. So x times x squared, x cubed, x times 2x plus 2x squared, x times negative 5 minus 5x. Now we're going to multiply the negative 3 by each term. So negative 3x squared, negative 6x, and positive 15. And then we'll combine any like terms. There's no like terms with the x cubed. There's a 2x squared minus 3x squared. That's negative 1x squared, which you can just write as negative x squared. There's a negative 5x minus 6x. That's negative 11x. And then there's a plus 15 at the end. So while this process is called distributive property, FOIL is actually the same process, but FOIL is a special distributive property for a binomial times a binomial. This example was a binomial, x minus 3, times a trinomial, x squared plus 2x minus 5. So you'd have to use distributive property. Okay, again, if you have any questions, please don't hesitate to ask. My name is Al Drushler.